Solve 3n plus 2 equals 4n plus 2. Again, we're faced with a situation where the variable is on both sides of the equation, and we know that we have to isolate the variable on one side. So the strategy is going to be the same as before. We need to eliminate one of the variable terms. Notice that if we subtract 3n from both sides, that will eliminate this 3n, and then 4n minus 3n is going to be 1n, which gives us a positive amount of n. So that's going to be the better choice here. Let's subtract 3n on both sides. When we do that, we have 2 on the left, and on the right, 4n minus 3n is just n. So we have 2 equals n plus 2. Now, to get n alone, we need to subtract this 2. So we subtract 2 on both sides. On the left, 2 minus 2 is 0. And on the right, the 2's cancel, and we're left with n by itself. So in this case, the solution is n equals 0. I don't usually check the answers every time, but we're going to do that here because sometimes students freak out when an answer is 0. You don't know why people are so afraid of 0, but it does work. So we said our solution was n equals 0. That means we need to substitute in 0 whenever we have an n in the equation. And we need to evaluate and see if the left and right-hand sides are equal. On the left, 3 times 0 is 0, so that gives us 0 plus 2. On the right, 4 times 0 is 0, so we also have 0 plus 2. And 0 plus 2 is just 2 on both sides. We get 2 equals 2, which is correct. Now, I want to show something that students do that's usually a bad choice. And I want to talk about why it's a bad choice. So we're going to look at the same problem, 3n plus 2 equals 4n plus 2. And what I want you to do is I want you to take a moment and I want you to solve this problem, but the first step I'd like you to do is to subtract 2 on both sides. A lot of times students see the 2's and they want to get rid of the 2's. So go ahead and pause the video and try to solve this problem after you've subtracted 2 from both sides. And when you're finished attempting, you can hit play again. I'll wait. Okay, so I'm assuming that you tried to solve this problem. Hopefully, you got n equals 0 as a solution, but there's a good chance that you got stuck, which happens quite often. Let's see what the problem is. If we subtract 2 from both sides, on the left, that leaves us with just 3n, because the positive and negative 2 cancel. And on the right, we're left with just 4n, because again, the positive 2 and the negative 2 cancel. And oftentimes when students get to this point, they don't think that this is possible. They say 3n can't equal 4n. They're different amounts of n, and they get confused, and they don't know what to do next. And so oftentimes students will just stop here, or they'll say it can't be done, or they'll go running and screaming. But we still can salvage this. It's just not as obvious to everyone. We still are in the situation where we have a variable on both sides. And earlier I said that when we have a variable on both sides, we need to eliminate one of those. And the way that we can eliminate the 3n is by subtracting 3n on both sides. A lot of students don't think to do this. So when we do this, 3n minus 3n is 0n, or just 0. Whenever we subtract something from itself, we're left with 0. On the right, 4n minus 3n is 1n, or just n. And we do end up getting the same solution, n equals 0. So it is possible to do it this way, but I discourage it because many students get confused here. And this causes a lot of students to get stuck. So when you're solving a problem like this, I don't want you to get distracted by the fact that there's a 2 on each side, and we can get rid of the 2's. That's not important. The important thing is to focus on the variables and realize that if there's a variable on both sides, we have to eliminate one of them in our attempt to get the variable alone. So it's very important to start with variables before you deal with constant terms.